So today we'll be talking about how you can block viral replication using reverse transcriptase inhibitors. And in this case, I'll be talking about HIV. So we're going to answer the question, how does one get infected with HIV and where does it go? So if two people are together, let's say a guy and a girl, not an artist, and the guy all of a sudden gets a cut on his arm, doesn't realize it, and the girl comes into contact with this cut or with this wound. She also gets just a little bit of blood on her arm, and somehow that blood is ingested. And the guy is HIV positive. The girl now who has ingested the blood will also be HIV positive. So from here, how does this work? So basically, after the blood is ingested and goes through your stomach, it will be absorbed into the bloodstream. So if this is all red blood cells, this is the HIV virus. Now you just have some HIV in your bloodstream, which this is one of the most prevalent places that you will find HIV, but it can also be in some other places too. And then from here, HIV can infect cells. And the way that it does this is HIV is an enveloped virus, which means that if you have HIV, this is the envelope that is around the virus. And if this is a host cell, the HIV is trying to get into this host cell. Now, how it does this is that it kind of fuses to the membrane and gets as close as it can and basically pushes itself through. So then, next step, it'll be like this, where it's entering. So it'll be like this, where it's entering, and then the next step is that it would be in the cell, and then this envelope that's around the virus, once it's inside the cell, it kind of like disintegrates, and then it just disappears, and then you're just left with a virus in the cell. Now, with just one virus in the cell, what happens after this? So when we say one virus is in the cell, it's basically that there is a bunch of different things in this virus. So there's a couple of RNA strands, there's different proteins in the cell, but talking specifically about the RNA strands. So this is good enough. A 5' to 3' HIV RNA strand. what happens with this is that there is this Pac-Man-like shape, and this is the reverse transcriptase. And what this does is that the reverse transcriptase will go through the HIV RNA and make a complementary strand, 3' to 5' DNA, and then it will make an exact copy of the 5' to 3' to make the double-stranded DNA. And then with this double-stranded DNA, it is how these viruses replicate. So when this whole process takes place, multiple viruses will be made. And this host cell will keep filling up with this virus until there is not enough room, and then it basically explodes. And then these viruses go on to infect new cells, and this process just keeps taking place. And this is called the lytic cycle of the process of the viruses being active and keep replicating, making more until they explode out of the host cell, and then keep doing this process over and over again. So what I will be talking about today is the medication So today I'll be talking about the medication tenofovir. And the way this is an oral medication, so someone takes this pill. Now they're all happy. And the pill goes down into the stomach, and it will also be absorbed into the bloodstream. So there's the red blood cells, and then here are the little particles of the tenofovir. So, how this works in relation to this and the lytic cycle and everything. So, we have the HIV RNA, and we have our reverse transcriptase, Pac-Man figure. And this is 5' to 3'. What happens with this is that when the reverse transcriptase is going through and making this complementary strand, this is going down to the base pairs and the nucleosides. So, drawing that out, here's the bottom. The nucleosides kind of just have different shapes. And so when the reverse transcriptase is going through, goes across, and it builds this top half. Let's make one more. So when it's building the top half, we'll say, okay, this first one, that connects, keep moving. This one connects, keep moving. that connects, keep moving, and tenofovir comes in, and it will connect, but at the end of this is like a stop. So if you have another DNA nucleoside trying to connect, it'll just keep bouncing off. You can't connect, it'll keep bouncing off. It doesn't have the right shape to hold anything or fit anything after this tenofovir comes in. So this is what completely stops the transcribing into DNA. Now for the other medication. So for the other medication, it's called doravirine. And what this does is we have our HIV RNA and our reverse transcriptase. So what happens with this is that with the doravirine, again, it's a pill that you take, you ingest. Happy because they took the pill, and it goes into the bloodstream again. Just like tenofovir and HIV, it's absorbed through the bloodstream. So, how this differs from the tenofovir is that there is, so the reverse transcriptase is trying to go through and make a complementary strand for the HIV RNA. But with doravirine, it completely blocks the reverse transcriptase. So basically is like this little triangle, and this is gonna go into like the mouth of the Pac-Man. So then that's the reverse transcriptase. This is the doravirine. And with this, if it tries to make the complementary strand, it's just gonna bounce off. It'll just keep bouncing off because there's nothing that it's able to get to with the doravirine blocking it. And that is the animation that I have. Thank you.